So the main thing about today is talk about how we sum up all the arithmetic sequences, all the individual terms in the arithmetic sequences. For example, if you add 1 to 100, 1 plus 2 plus 3 plus 4 plus 5, do you use your calculator or do you use recognizing the pattern of adding 1 and 100, 2 and 99, and so on and so forth? Alright? So what we're doing today is basically define the series is a sum of a sequence, determine arithmetic sums using a recursive process, derive the arithmetic sum, which is series formula, and use it to calculate the sum of n terms, find the common difference, first term or number of terms given sufficient information, and apply arithmetic sums to applied problems involving linear growth and decay. Now, I'm going to ask you to think about the arithmetic sequence 2, 5, 8, and 1. Can you write down the recursive rule and the general rule, please? So what is the difference? What is D? What is A? You should be able to write down the recursive rule, and you should be able to write down the general rule. Alright, that is what I have as a recursive rule. I specify T1, I know Tn plus 1 equals to Tn plus 3. And the general rule is therefore Tn equals 2 plus n minus 1 times 3, which after expanding and simplifying is 3n minus 1. Right? So now, what I want you to think about is consider the collective sum in the terms in the sequence. And if Sn be the sum of the n terms of the sequence, so for example, S1 will be the same as T1. Because T1 added by itself is just you're not adding anything on. So S1 is always the same as T1. Whereas S2 will be T1 plus T2. S3 is T1 plus T2 plus T3. And you know that T1 plus T2 is S2. So it's therefore S2 plus T3. Correct? S4, T1 plus T2 plus T3 plus T4. And you know that T1 plus T2 plus T3 is S3 plus T4. You could work that out if you want to. Keep adding. So we could now recognize that Sn is actually Sn minus 1 plus Tn. So the sum of n terms in the series is the sum of the n minus 1 terms plus the term itself. Alright? Now, if we use arithmetic sequence, which is a plus d, a plus 2d, a plus 3d, what we could do is we could substitute all this into S1, S2, S3, S4, and then we can generalize Sn as a plus d, a plus 2d, a plus 3d, until such date that we have a plus n minus 1d. Now the question is, how do we derive a generalized equation for that? Alright? You don't have to know that in the exam, but I do need to show you. It's a way of learning how to prove in mathematics. So if you know Sn is this, notice that I highlighted the colors, a plus d, and so on and so forth. Writing these terms in the reverse order. We could do it in the reverse order. So we started off with that. And then this, and slowly the second and the last term. Alright? Math's way of proving. What you do is add both of them together. So therefore we have 2Sn equals to all this. Alright? A plus n minus 1d. A plus d plus a plus n minus 2 times d, and so on and so forth. Alright, why do I do this? A way of proving for maths. So we have 2Sn, which is that. Can you see when I added the a, what happened? Are they all the same? Yeah? Alright. So when they are all the same, it's n lots f2a plus n minus 1d, correct? So if that's n, you may have n lots of this. So think about how maths prove something. You've got one equation equals to something, and you write the terms in reverse order, and then you add them all together so that you come up with some sort of pattern. Maths is looking at patterns. Alright? Yes?
The last term is n minus 1. Why is it n lots of 2a?
Yeah, because this is n Sn. Alright? A. Let's go back one step. Thank you. Pardon. Let's go back one page. If I can get that. Alright. So, now, going back one page, when we generalize, S1 plus is the same as T1 equals to A. Correct? That's the first term. So S2 will therefore be S1 plus T2, which is A plus B, and so on and so forth. And if you look at that, S4 will be S3, which is the sum of T1, T2, and T3, which is A plus D, A plus 2D, A plus 3D. So therefore, it is, first one is A plus 0D. Second term is plus 1D. So it's n minus 1, correct?
Yeah.
Got it? Good. So this is the way of how we could actually generalize. It's really interesting in terms of maths, how you rearrange things, how you add things or multiplying things, and you can work out 2Sn equals to n times 2a plus n minus 1d. So therefore, the equation you need to know is Sn equals to n over 2 into 2a plus n minus 1 times d. And the sum, this is the sum of an arithmetic sequence, Tn, is called arithmetic series. So if we know the first term a and the common difference d, this is what we could use to find the sum. As long as you know a, as long as you know d. And then you know the terms. Now, if we know the last term of the series, which means there's a finite series, a and the last term, which is L, we can write Sn equals to n over 2 times a plus L. Alright? Think about it. When we look at 1 plus 2 plus 3 plus 4 plus 5 to 100, we know the sequence is 1, and then n plus 1 is plus 1 plus 1 plus 1. D is 1, A is 1. So therefore, if L is 100, 1 plus 100, 1 plus 100, 101, and N is 100 divided by 2. You can use that to work out what the sum of 1 to 100. Yeah? Alright, that's a classic series example. Alright, let's go on to do some examples. So with that, can you actually, for this sequence, can you determine S2 and S10, S50? Yep, S2 is pretty straightforward because S2 is just 10 plus 17, which is 27. Whereas for S50, you should use this formula. You know that Sn is n over 2. In this case, 2a, a is 10, 20, plus n minus 1 times d. The difference is 7. Correct? So therefore B, S50 will be 50 divided by 2, 20 plus 49 times 7, which is, I'll let you work it out. Pretty straightforward. This is possibly the most basic example I can give you. Now what we're going to do is, this lesson, I want to go through exercises only. Can you do exercise 1 on the handout? And then I'll discuss it. Alright? How would you do a question like this? I mean, something like A, the sum of S2, the sum of T1 plus T2. That you can straight away write it out. Part B is the same as well, but part C and part D, you need to be able to use your equation. which is this equation here. All right, you must be able to write out Sn and then work out S1 Newton. All right, in this case, what is A? What is D? 9. A is 9. D is -4. All right? I've got my solution written out already, so makes it a little bit easier to read. Give you a couple more minutes to do that. Use the equation I gave you. But for the first two, just think about T1 is 9, T2 would be 5. So you could work out what A and B is just by basically using T1 and T2. All right, I shall reveal my answer. Okay, so if you know A, you know D equals to -4. So therefore, you could work out T2. T2 is just 5, correct? So therefore, S2 is 9 plus 5, which is 14. B, S1 is 9, S2 is 14. You could work out S1 minus S2 squared, which is -5 all squared, therefore 25. C, you should be able to use this equation. Sn equals to n divided by 2 into 2a plus n minus 1 times d. All right. So substitute all the numbers in. A is 9, d is -4. Therefore, Sn equals to n over 2 times 22 minus 4n. Substituting again as 100, you should be able to get the answer. Yeah. All right. I would like you to try 3, please. So the sum of the first n terms of an arithmetic sequence is given by this. Find the value of the first term, A, and the common difference. How would you do this? How would you use the information here to work out A and D? All right? Recall I said things about maths. How would you use maths to help you? How do you recognize a pattern? Now, how many unknowns are there? How many unknowns are there? Hang on. Sorry, I should ask you to do exercise 2 first, not exercise 3, this one. My fault, my fault, my fault. Let's do this first, exercise 2 first. Not 3, let's do 2 first. Now, if you've got a question like this, pi is just a number. Treat pi as 3.14, it's just a number. It's not a variable or anything. Pi is just a number. And if you're given a question like this in a calc free section, what you need to do is give it in the exact value, which is pi, in terms of pi. Give it in terms of pi. You do not have to evaluate pi. So here, if you know T1 and T20, we are given a finite series already. So you know the last term is 20 pi. So you could use this, correct? You know T1 is pi, T2 is 20 pi. You could use that. Sn equals to n over 2 into a plus l, where l is the last term. Let's do A first, and then think about B. B, there are two ways of doing it. All right? B is a very interesting question. I wrote down one way, but there's actually another way of doing it. Now, I will reveal my answer. Oops, wrong button. Alright, for exercise 2, you can see that we know T1 is pi, T20 is 20 pi, which is last term. Therefore, we can use S20 equals to n over 20 a plus l. So 20 over 2 into pi plus 20 pi is 210 pi. Now part B, I've done it a different way where I determine the D and A first. However, you don't actually need to do that. If you know Tn is 5 minus 3n, you could actually substitute T40, correct? Which means you've got the last term. And you can work out what the first term is. Correct? When n is 1, 5 minus 3 is 2. And then when n is 40, it's a negative number. Alright? 5 minus 120 is 40, 120, 135. So you could work it out. A plus L divided by 2. So two ways of doing it. I'm just showing you a way of finding D and A first. It really doesn't matter. Alright? Now, next one I would like you to try is question 3, which is this one over here. This one is really an interesting one. How many unknowns are there and how many equations do you need to solve? What do we need in this case? We need the A and B. Alright? Now, think about it. We know Sn is also the same as n over 2 into 2a plus n minus 1b. Alright? Can we equate this and that and see if we can solve it? Now, knowing that n is common for both, we've got two equations, n is common for both, we need to find a and d. So think about if you could equate 3n squared minus 8n equals to n over 2, 2a, n minus 1 times d. Alright? And how do you solve for a and b? It's interesting because in this case, we do have, in a way, three unknowns. N is still unknown, but n is common for both. So what will you do? You are going to find the coefficient of n, correct? Then you can equate both sides. This, like I say, is the beauty of maths. Alright, so if I equate both equations, I've got Sn equals to, that is the generalized equation we use to find the sum. Sn equals to n minus 2, 2a plus n minus 1b. And this is already been derived for you, 3n squared minus 8n. So if I equate both, alright? If I equate both, we can actually expand this. Alright? We can still expand this. We can actually factorize that. Or we don't actually need to expand this, we need to factorize that. Once we factorize, we can actually, in this case, because n is actually, although it's unknown, it's on both sides, and it's actually a number, it's the term. Alright? So it's the, we can factorize and divide both sides by n. So therefore, we've got 2a plus n minus 1b equals to 6n minus 16. Then, expanding this, you can see that 2a minus d is actually minus 16. dn equals to 6n. And therefore, you know dn equals to 6n, d equals to 6. 2a minus d is minus 16. You already know your d. You can solve for a equals to minus 5. Alright? Just remember, in this case, n is common for both. N is also just a term number. This is how I would solve it.
So if you divide by n, you would not do this solution.
Right.
No.
Sorry?
If you divide by n, would you not lose the solution?
We are only looking for one solution in this case. In this case, because n is common for both, and it's also just the term number. All right. Unique one. All right. I would like you to try 4, please. So you should be able to find out the expression for the common difference of the sequence. And then use that to find an expression for the sum S14. Yeah, these are the sort of question that potentially will be solved.
Yeah, that's right.
All right. Check that I've done A and D correctly. A is given straight away. D, you need to use 5x plus 5 minus 2x plus 3, which will give you 3x plus 2. All right. From there, you should be able to sort out what S14 is by using your D as 3x plus 2 and A is 2x plus 3. Question 4? Which one? D, the common difference is exercise 4. Common difference is not 8. Common difference is 5x plus 5 minus 2x plus 3, which is 3x plus 2. You got to include the x in there. See, this is T2 minus T1. They'll give you 3x plus 2. You have to include the x in there. You must include the x in there. Problem solving, you must include the x. Right? If you include the x, you know that the d is 3x plus 2. It's equations for you to solve. You have to derive an expression as well. What is the consensus for x? What did you get for x? 2. Good. Thank you. So I found D is 3x plus 2. Did that either on the whiteboard or T2 minus T1, which is 3x plus 2. So therefore, substituting, you know x14 is 14 over 2, 2x plus 3 plus n minus 1, which is 14, times 3x plus 2, which is the D. And then, expanding everything, you will find S14 equals to 310x plus 224. Since S14 is 826, therefore x equals to 2, then substituting into part D, you'll be able to work out, substituting into whatever it is, T1 equals to A plus 2 plus 3, so you should be able to find out what D is. Once you know what x is, you can work out T1 and T2, and you can work out D, which is 8. So therefore, Tn equals to 7 plus 1 times n minus 1 multiplied by 8. And expanding it is minus 1 plus 8n, or 8n minus 1. Alright, exercise 5 please. Question 5 for you to do. A 15-year service contract involves a company paying 120,000 in the first year of a contract, with an annual increase of 800 every year after that for the life of the contract. You need to determine the amount. This is pretty straightforward because you do know what A is, you do know what D is, and you know what the term is, which is 15 years. You need to sum the first 15 years. Something like exercise 5 would be a warm-up question in the exam, I would say. So if there's an annual increase of $800 every year, the difference is 800, correct? So D is 800, A is 12000, and you can work out X 15. This is how I did it. I want to go to question 6, which is a bit more complicated. Alright? So I basically wrote down what A is, or what T1 is, and D. So once I know A and D, I can just substitute the formula in, and it's actually $264. Alright, I would like all of you to spend some time to think about question 6 now. Exercise 6. That is the more interesting one. How you would solve it, and how you would think about the way of solving it. Oh, by the way, the typing is incorrect. It's determine the amount of interest Max has to pay his parents. The last sentence. I left out the X. Yes? Sorry? First common difference is second term take away first one. Yeah. That's one. Sorry? Yes, T2 minus T1. Yeah. T2 minus T2 is 0. No, it's the same, it should be the same, T3 minus T2. Oh, that's not right. That's not the way of doing it. This is still arithmetic sequence. This is still arithmetic sequence. This is a tricky one. This requires some sort of a thought process. D2 minus D3 should be always the same as D3 minus D2 is the first common difference. So if you cannot find the first common difference, then there's something incorrect. Now, I'm going to give you a hint. I'm setting out a table here. I'm setting out a table with end of the month, the balance, and the interest. You are only looking at the amount of interest Max has to pay his parents. Alright, this is a hint. How to do this using a table.
Calculate every single one.
No. Recognizing the pattern. Recognize the pattern, please.
You have to reduce $1,000 and then you have to reduce 1% of the balance. That means you
Write out the table, write out the balance. Alright, one hint.
At the end of each month, we lose $1,000. So you get to zero.
Is that good enough hint?
Yeah, it is. Okay, he paid this.
So think about it, end of the first month, he still owes 224,000, so what is the interest? And then he pay back 1,000, so that is, end of the second month is $23,000. What is the interest? If you keep going until month 24.
$3,000 interest. No, it makes so much more sense, right?
With the table, it makes so much more sense, right? So let me show you my solution. It makes, okay, this is one way of solving it. I mean, I'm sure there are other ways, but once you've got the table, straight away that you can see that it goes from 1 to 24, and then it reduces first for 24,000 to 23,000 to until the end is $1,000. So therefore, the interest is 240 plus 230 plus until the last bit, which is 10. All right? Once you realize that, you can use your Sn equals to n over 2, a plus l, or you can use a and d. d is minus 10. Either way, it doesn't matter. You will work out the interest is $3,000. All right, I'm going to stop here. There should be enough exercises for you to do on from Sadler, I think.